Now the reason this command is called union and not like stack or something else is that this is a set terminology, right? This comes from the mathematical theory of sets, which you might remember from school. And the idea is that a table is simply a set of rows. So this table over here is a set of 2 rows, and this table over here is a set of 2 rows. And once you have 2 sets, you can do various set operations between them. And the most common operation that we do in SQL is unioning. And unioning means combining the values of 2 sets. So you might remember from school the Venn diagram, which is a typical way to visualize the relations between sets. So in this simple Venn diagram, we have 2 circles, A and B, which represent 2 sets. And in our case, A represents the collection of rows in the first table, and B represents all the rows that are in the second table. So what does it mean to union these sets? It means taking all of the elements that are in both sets. So taking all of the rows that are in both tables. And what is the difference here between union distinct and union all? Where you can see that the rows of A are this part over here plus this part over here, and the rows of B are this part over here plus this part over here. And so when we combine them, we're actually counting the intersection twice. We're counting this part twice. And so what do you do with this double counting? Do you keep it or do you discard it? If you do union all, you will keep it, so rows that are in common between A and B will duplicate, you will see them twice. But if you do union distinct, you will discard it, and so you won't have any duplicates in the results. So that's one way to think about it in terms of sets. But we also know that union is not the only set operation, right? There are other set operations. A very popular one is the intersect operation. Now the intersect looks like this, right? It says take only the elements that are in common between these 2 sets. So can we do that in SQL? Can we say, give me only the rows that are in common between the 2 tables? And the answer is yes, we can do this. And if we go back here, we can, instead of union, write intersect and then distinct. And what do you expect to see after I run this command? Take a minute to think about it. So what I expect to see is to get only the rows that are shared between the 2 tables. Now there is one row which is shared between these 2 tables, which is the one true yes row, which we have seen. And if I run this, I will get exactly this row. So intersect distinct gives me the rows that are shared between the 2 tables, and I have to write intersect distinct. I cannot write intersect all because actually it doesn't mean anything, so it's not going to work. And here's another set operation which you might consider, which is subtraction. So what if I told you, give me all of the elements in A except the elements that A shares with B? So what would that look on the drawing? It would look like this, right? So this is taking all of the elements that are in A except these ones over here because they are in A, but they're also in B, and I don't want the elements shared with B. And yes, I can also do that in SQL. I can come here and I could say, give me everything from toy 1 except distinct everything from toy 2. And what this means is that I want to get all of my rows from toy 1 except the rows that are shared with toy 2. So what do you expect to see when I run this? Let's hit run. And I expect to see only this row over here because this other row is actually shared with B. And this is what I get. Again, you have to write except distinct. You cannot write except all because it actually doesn't mean anything. And keep in mind that unlike the previous two operations, which are union and distinct, the except operation is not symmetric, right? So if I swap the tables over here, I actually expect to get a different result, right? I expect to see this row over here selected because I'm saying, give me everything from this table, toy 2, except the rows that are shared with toy 1. So let us run this and make sure. And in fact, I get the 3 true maybe row. So careful that the except operation is not symmetric. The order in which you put the two tables matters. So that was a short overview of union, intersect, except, and I will link this here, which is the BigQuery documentation on this, and you can see that they're actually called set operators. In fact, in real life, you almost always see union. Very rarely you will see somebody using intersect or except. A lot of people also don't know about them. But I think it's worth it that we briefly looked at all three, and it's especially good for you to get used to thinking about tables as sets of rows and thinking about SQL operations in terms of set operations, and that will also come in handy when we study joins.